At some distant point in our galaxy, silently orbiting a star that we can hardly see with the naked eye, there may exist a world that looks very much like Earth, but at the same time is radically different from it. It is not a hellish planet like Venus, nor a gas giant like Jupiter. We are talking about a possible rocky planet, similar in size to Earth, but shrouded in extreme cold. A world known as HD 137010b. In scientific media and specialized reports, HD 137010b has come to be called Frozen Earth or Cold Earth. These nicknames arose almost naturally because whenever a planet has dimensions and an orbit similar to that of Earth, our imagination is immediately activated. We think of oceans, atmospheres, climate cycles, and even the possibility of life. However, in this case, the cold may be the dominant factor. The most important thing is that HD 137010b is still not an officially confirmed planet. It is classified as a candidate. This means that its existence has been identified from indirect signals, extracted from the reanalysis of old data from the Kepler telescope, and it is still awaiting independent observations for definitive validation. The Kepler telescope was one of the most revolutionary tools in modern astronomy. For years, it continuously observed the brightness of over 150,000 stars, looking for small dips in brightness caused by planets passing in front of their stars. This is how thousands of exoplanets were discovered. However, not all the signals detected by Kepler were fully understood at the time. Computational limitations, noise in the data, and conservative criteria led to many possible planets being initially ignored or classified as inconclusive. Years later, with new statistical methods and more sophisticated algorithms, astronomers began to revisit this data. Patterns previously considered noise started to make sense. Subtle signals became plausible evidence. It was in this context that HD 137010b emerged. Initial estimates suggest that HD 137010b has dimensions very close to those of Earth. It does not appear to be a swollen planet or an overly compressed world. This structural similarity places it in an extremely interesting category from a scientific perspective. Besides its size, the orbit of HD 137010b is also noteworthy. In terms of its distance relative to its star, it is not radically different from Earth's orbit around the Sun. However, the star it orbits is less luminous and emits less energy. As a result, the amount of energy received by the planet is significantly lower. This implies much lower average temperatures, possibly below the freezing point of water across nearly the entire surface. On the planet, even the coldest environments still show seasonal variations, partial thaws, and adapted ecosystems. On HD 137010b, this type of dynamics may simply not exist. The cold can be constant, deep, and permanent. Even so, the fact that HD 137010b is likely rocky is fundamental. Rocky planets preserve clearer records of their formation, composition, and thermal evolution. They are natural laboratories for us to understand how Earth-like worlds can follow completely different paths. One of the great mysteries is the atmosphere. We do not know if HD 137010b has a significant atmosphere. If it exists, it could be thin, thick, or composed of gases very different from those found on Earth. The presence or absence of an atmosphere completely alters a planet's thermal fate. Without an efficient atmosphere, the heat received from the star quickly dissipates into space. With a dense atmosphere, even a distant planet can retain enough heat to maintain higher temperatures. In the case of HD 137010b, everything indicates that the greenhouse effect, if it exists, is weak. This planet also forces us to rethink the classic concept of the habitable zone. For a long time, we believed that it was enough to be at the right distance from the star for liquid water to exist. Today we know that this definition is simplistic. There are worlds that are too hot, too cold, too dense, or have hostile atmospheres. HD 137010b seems to occupy an extreme point of this spectrum, showing that the similarity to Earth may be only geometric and not environmental. Therefore, scientists are cautious. HD 137010b is still awaiting definitive confirmation. Future observations with more modern telescopes and independent measurements will be essential to validate its existence and refine its parameters. If confirmed, the planet will join a growing class of Earth-sized planets that challenge our expectations. Worlds that seem familiar at first glance, but hide extreme realities. But more than a possible frozen planet, it represents a powerful scientific lesson. It shows that there are still extraordinary discoveries hidden in old data, just waiting for new questions and new tools. Whether it is a real frozen land or a signal that will still be discarded, HD 137010b has already played a fundamental role. It has made us reflect again on what truly makes Earth special. In a universe with billions of galaxies and trillions of planets, understanding these extreme worlds is also a way to understand ourselves. Because by studying cold and silent planets, we better understand the rare balance that allowed life to flourish here. If you want to keep exploring the mysteries of the universe, discovering extreme worlds, and understanding our place in the cosmos, follow us.